Alright, another help request for exercise 8.3, so let's take a look. Okay, so it looks like we have separate code for parallel and series, but I'm going to go ahead and take a look at series first. So case 1, 2, 3, fine, we'll see where those are defined. Inlet concentrations, good. Vector of residence times or taus, that's good. Initial guesses for A, B, and C, good. So presizing vectors for A, B, and C, then you had listed the three cases, so okay, that's good. So there's going to be vectors that collect the results. I'm going to loop over a vector of tau. And it looks like we just have a separate error function for all three cases. We'll take a look at that. Let's take a look at that now. Okay, and so our error function is going to have an input of x, which is going to be our vector of concentrations we're solving for. Okay, so it looks like even your issue just might be, well, no, I take that back because then it's a case, and then you give it tau I. Okay, so let's look at. So actually, this is a script then with the local function, and so you don't see this. I don't mention this at all in the text because I want to say it was only like MATLAB version 2015 where they started to allow you to have local functions within a script. So your error functions, you redefine your initial concentrations, okay? And what I would say is you might as well just pass it up here then, right? So that it only needs to be done once, okay? And my preference is to put things up top. Okay. So this, won't make a difference at all in terms of your code working. It's just you don't need to do it on the top and the bottom. Okay. Just like when it comes to stoichiometric coefficients, are those up here? No, right? But if we, oh man, you got all these error functions. Shoot, I forgot that you need to do for all of them. Okay, so actually maybe let me stop trying to generalize it, but you might also think about putting those stoichiometric coefficients up top. So maybe let me get the code working and then we could play with tidying it up like that. Okay, so let's get it working, then we could tidy it up and get rid of the stoichiometric coefficients. Well, stoichiometric coefficients could go in the top function, as could temperature, gas constant, activation energy. Okay, yeah, because you have the cases hard-coded, so case 1 would be 0.1, right? But yeah, in some of the other codes you'll see it make the main function have an input of multiple, and that's something you could always pass to your error function. And then, in theory, you'd only need one error function. Okay, but let's get it working, and then we'll have some fun. Okay. Then you have your rates hard-coded in. Nothing's jumping out to me in terms of being wrong. Fractional conversion. You just have a single compact plot command. That's fine. So I don't necessarily see anything wrong. Okay, I would agree. Your figures, you got a lot of figures. Yeah, your concentration looks wrong. Okay, so let's take a look at that. Alright, let's try and make sense of this. So there's my initial concentrations. Initial gases is fine. Those are just the collection vectors. So if you look at your air function, this is series. A goes to B, B goes to C. Okay, not. It's fine. -1, you could just make that -E and that would be fine. But it's not a big deal. Is this right for... I'm wondering, I don't know if this looks right. So I'll just bring up Wikipedia. I think your gas content might be just calories. It says oh yeah, so what you have in your gas constant is just calories. All right, and why I say that is the only value I remember is this 8.314, which is joules per mole Kelvin. And then the conversion factor from joules to calories, so there's 4.184 joules in a calorie. So what I think you have here then, this is either the -3. Okay. Now let's just see if that in itself is enough to change things. Yeah, that alone fixes it. Hold on, I thought it did. Oh, it's because I only fixed it in one of your reactions, or in one of your cases, right? So looking at, I don't know, it must be case 1, right? Now that looks right. So let's get it working in all the cases, and then while we're at it, since you reached out to me, I'm going to have some fun with your code. E -3. E -3. Okay. This is just series, but I would guess that in your parallel code you probably have the same issue. Bam. All right, looks good. Probably just want to make tau bigger. Man, so many figures. Okay, let me just close that for now. All those are all comparison plots. So you probably just want to make tau bigger, because in series you should see B go through an extremum. So that'd just be a matter of making tau bigger. Okay, so tau should probably definitely be larger than what you have. Okay, but yeah, I'm gonna have fun. Okay, so the first thing I'm gonna do is you just copied and pasted, these 3 different cases. That's fine. Okay, what I'm gonna do though is I want to make it so that you just have one general air function. Okay, and how I'm going to do that is I didn't delete everything. So you had case 1. Okay, I'm going to add as an input multiple. Okay. And then what I'm going to do here is this is just going to be multiple. Okay, watch this. So just added that, case multiple as an input. Okay. Up here then, I'm going to create this multiple matrix. Okay, so case 1 would be 0.1. Case 2 will be 1. Case 3 will be 10. Okay, save that. And so then here, okay, so case 1, okay, my anonymous function, which will be my error function for case 1, I'll just use multiple, the first element of that multiple vector. Okay, now for case 2, okay, I can use the same general error function, which I just left as case 1, but now it's going to use multiple 2. And then your third anonymous error function will still refer to that general error function case 1, but it's going to use the third element of that multiple vector. Okay. All right, so if I run this, okay, I should get exactly the same thing, but now, oh man, I broke it. Did I forget something? Shouldn't have, unless you've got something I didn't notice. Multiple. Okay. So I said multiple. Spell multiple right. Multiple. 1, 2, 3. And then when I call my error function, that's stored in multiple. Okay, now I'm just in trouble because it looks like, I spelled it wrong somewhere. Multiple. Okay, bam. Okay, good. So I just had a spelling error. So now that works, right? And the benefit of this is now I just need one general error function. And then for the 3 different cases, for each case, I can just pass it a different value of the multiple I want to use for that case, right? And so my guess is you probably wrote the error function once and just copied and pasted it twice. And for each case, you just manually change the multiple. But, here I was able to do it in a general way, okay? Then the other thing I would probably do in terms of, messing with your code, which I won't in the interest of time, but, and it makes it easier now that you just have one general error function. But I would probably make the stoichiometric coefficients. I would define those up in the top of the script and then just add those. So pass those also to this general rate expression. Same thing with T, R, and E. I would define those in my script and then just pass those via my anonymous function to my function. And yeah, K0.1 is constant. You could even predefine that up top. Even K0.2, right? You could not even pass multiple. You could do that up top, right? So a lot of these things that are constants and don't change each iteration, I probably would define in my script and then pass them down, just to give you some flexibility if you wanted to look at a slightly different, take on this problem, that you just update those parameters in the top function and have added. Okay, but the only thing we found that kept your code from working before is, R, your gas constant. You were a factor of 1,000 too big, and so then if you look at your Arrhenius equation, R was too big by a factor of 1,000. Right, so E over RT then would be too small by a factor of 1,000, and so then that's a negative. So actually, it's an inverse. So then, this would would be what? Well, it's an exponential, but exponential of a negative, it's you flip it. So this would be e over, or 1 over e to the e over rt. And so, yeah. In fact, I guess in your case, what you would make it too small, so your rate's too large, right? So the reason it goes quickly to 0 is your actual rate is way too big.